All right, comparison operators are not terribly complicated in any way. Pretty simple and intuitive to understand, and we're going to go through some very rudimentary examples right up here at front, but I assure you that as we move on, we're going to enter some use cases where these things become utterly vital to you. They're very useful for finding elements in a large set of elements, whether that be a vector like you've seen already, or a data frame, which is going to be one of the core objects we work with later on, finding elements within those big groups of elements that meet certain criteria. So let's look at some of the criteria you can apply. The first ones we're going to look at are greater than and less than. So this is how you ask R to evaluate. Is 1 less than 2? And we'll go ahead and operate. You'll see that R returns true. For each of these operators here, these comparison operators, you're going to see it return logical values, which means it's either going to be true or it's going to be false. And there is that third case, just like there is in the real world here, that you encounter an error. There's a problem. It gets more complicated than that. Now in R, that generally just means you did something wrong and it's broken. But is 1 less than 2? We say yes, that's true. However, is 5 less than 3? Will return false each and every time. All right, and the greater than operator works in a very similar way. We can see, yes, 3 is greater than 2.997, but no, 3 is not greater than 3. So it works to test for whether or not something is greater than or less than something else. All right, you caught me cheating. I added some material in here to the console between shooting videos because I realized I'd made a heinous oversight, and that was failing to show you the less than or equal to and greater than or equal to comparison operators. Let's take a quick look. Is A less than or equal to 3? And that's going to evaluate with an error. I warned you early on, you can run into those when you're doing these types of evaluations. It's looking for an object of the name A. If I put A in quotes, it would have been a character. Let's see how that evaluates. There's no object of the name A saved here, so that's what it looks for first, finds nothing. If we do quote A less than 3, it evaluates to false. We'll get to that a little bit later about comparisons between variables of types that don't match, but in this particular case, A less than or equal to 3 equals false. How about we put these symbols in? Now that's the assignment operator. Now we have A equal to 3. And that's something you have to watch out for because those things look an awful lot alike, and it's not a difficult typo to make. So if we evaluate just A by itself, see it comes out 3. So now is A less than or equal to 4? Why, yes it is. Is A less than or equal to negative 1,768? No, it is not. Goes to show in operators like this, you certainly can use a variable to compare to a number or to another variable or to the result of a function or any number of other things. They work pretty well across the board, but for the sake of teaching, it's significantly easier to show it to you folks in the context of, natural numbers or pretty intelligible numbers. So, you got me slipping again. Looks like I had too many less than or equal to, not enough greater than or equal to, but it's all learning experiences. This goes to show you that when you create things to share with other people, especially in code, you got to take the time to make sure it looks right before you put it out there in the world. So there you go. You're welcome. I'm glad I could share that lesson with you. Let's take a look at how greater than or equal to evaluates. It's not going to surprise you very much at all in each of these cases. It's only going to evaluate as greater than or equal to things that's greater than or equal to. Nothing too wild. The next operator we're going to take a look at is the one that measures for equality, and that is the double equal sign. Now, if you recall from previous videos, and I'm quite sure that you do, the single equal sign can actually be used in assignment, much like our combination of that less than sign and the dash, that little arrow we make. Equal sign can be used interchangeably with that according to the interpreter. We don't do it for sake of style, but that symbol's taken, so the double equal is how we measure equality, or rather test for it. So is 1,000, no. How about is 19,753 equal to 19,753? What do you know shoots out true? Now this one works real well for characters as well, so ABC equal to ABC. And it works for logical values also. You can see here, what we're evaluating is true equal to capital T. And in the context of R, the letters capital T and capital F without quotation marks correspond to the logical values true and false, respectively. So capital T, capital F, interchangeable with the full names. Now you can't use lowercase t, lowercase f, or have any of the letters in those words true or false be lowercase and have it successfully evaluate as a logical value, logical variable there. So if we take a look here and add some stuff in, let's look at true. Oh, let's spell it right. The TRUE, let's evaluate that. Error, object true not found. And look at this, we could assign it a value also. You could assign it the value of 5. And it comes out as 5. You could also assign true the value of f, right? Then you go ahead and evaluate these two lines here, and what you're going to come out with is false. So only all caps, true and false, evaluate as true and false, logical values. Something worth knowing there. Moving further down the list here for our examples of equality, is 5 equal to a string of characters that spells out 5? No, false, it is not. How about is 1 equal to 0 point many nines? And the answer to this one may surprise you. With a sufficient number of nines, the answer is yes. Now, there's a couple things to learn here. One is that 0.9 continuous is equal to 1, which, if you haven't read that Wikipedia article, check it out. Blew my mind for sure. 2 is that R is doing some rounding in the background, and it's not always explicit about it. And I don't mean to scare you with that. It only does it with very long decimals. But it's something you should be aware of from the outset. It's one of the idiosyncrasies of language that can sneak up on you. All right, so we hit equality. Let's take a brief look at inequality. This one is written with the exclamation point and the equal sign adjacent to one another. It'll evaluate whether or not the terms on either side of it are equal to one another. And if they are equal, it will return false. In any other case, it will return true. So let's take a look here. Is 7 not equal to 5? The answer is true. They're not equal. Is 7 not equal to 8 minus 1? Answer is false. 8 minus 1 equals 7. So list of comparison operators, something I wanted to show you before we got into the real nitty-gritty, because you're going to need them sooner than later. Now you have them. Again, my name is Ed, working for mybringback.com. Please take the time to follow, subscribe on YouTube. Do what you got to do to keep a constant stream of My Bring Back pouring into your brain.